Today, the reduction of camphor, a ketone, by sodium borohydride into borneol and isoborneol alcohols of varying stereochemistry. You will not be responsible for the mechanism for this reaction, but given a ketone, such as camphor or some other ketone, be able to determine the product of the reduction to the alcohol. The sodium borohydride is slightly hygroscopic, okay, and it will clump. So it will be in the instrumentation room underneath the snorkel, and it should remain there when it's not being used. It can also decompose, so it can be a source of basic borate salts, which are caustic, so be careful when handling that. 0.65 grams would be a 1-to-1 ratio with the amount of camphor you're using today, while the PDF calls for 1.5 grams. Okay, why so much then? Okay, that's almost 3 times what you would need based on the molar amount of camphor. Well, some of it will be water that's complexed in there as a hydrate. Some of it will be a basic borate salt and not sodium borohydride. And the solvent today is methanol, and it will react slightly. Some of it will react with the methanol, and so you need almost 3 times a multimole ratio in order to really get the reduction of camphor accomplished. You're going to do this in a beaker on the hot plate, but don't let it sit undisturbed. Keep swirling it, keep agitating it. You don't want to overcook it, and that will certainly happen if you walk away from it. The melting point of the isoborneol needs to be done prior to the end of the lab period the next week and the product turned in. In addition, the following week you're going to take a small amount, and it's really small, and dissolve it, and we will analyze the content, borneol versus isoborneol versus unreacted camphor, via gas chromatography. The rest of the procedure, though, is as written in your PDF.